The farther we look into the universe, the farther we travel back through time. Every beam of light captured by our telescopes began its journey long before humanity ever existed. Some photons have crossed billions of years of expanding space before finally reaching Earth, carrying with them a snapshot of an ancient cosmos. In a very real sense, every observation is a glimpse into history rather than the present. For generations, however, our view of that history remained incomplete. Vast clouds of cosmic dust concealed enormous regions of space, while the expansion of the universe stretched the oldest light into wavelengths invisible to ordinary telescopes. The earliest galaxies, the first generations of stars, and the birth of large cosmic structures remained hidden behind a curtain we simply couldn't lift. Then everything changed. When the James Webb Space Telescope began its scientific mission, astronomers expected breathtaking discoveries. They hoped for sharper images, better measurements, and a clearer understanding of the universe's earliest chapters. What they didn't expect was evidence that would challenge some of the assumptions behind our current picture of cosmic evolution. Instead of revealing a young universe filled with tiny, primitive galaxies, Webb started detecting objects that appeared surprisingly bright, unexpectedly massive, and remarkably mature for their age. Some seemed to have formed far earlier than many theoretical models predicted, forcing scientists to ask an uncomfortable question. Have we underestimated how quickly the universe grew up? That question lies at the heart of one of modern astronomy's greatest mysteries. The James Webb Space Telescope represents decades of engineering, international cooperation, and scientific ambition. Launched on Christmas Day in 2021, the observatory traveled nearly 1.5 million kilometers from Earth to its operating position near the Sun-Earth L2 point. There, protected by a tennis court-sized sunshield and operating at extremely low temperatures, Webb became the most powerful infrared space telescope ever built. Unlike traditional optical telescopes, Webb was designed to detect infrared light. This difference is far more important than it may first appear. Infrared wavelengths allow astronomers to see through thick clouds of dust that block visible light, exposing stellar nurseries, hidden planetary systems, and galaxies concealed behind enormous cosmic clouds. Even more importantly, infrared allows us to observe the oldest objects in existence because the expansion of space stretches ancient light into longer wavelengths before it reaches Earth. Without infrared vision, much of the early universe remains invisible. With Webb, those hidden chapters finally became accessible. Within months of beginning operations, the telescope started producing observations unlike anything astronomers had seen before. It revealed extraordinary detail inside nearby nebulae, mapped distant planetary atmospheres, observed galaxies colliding across millions of light years, and captured some of the deepest images ever recorded. Yet each new discovery seemed to raise even more questions. Rather than confirming every expectation, Webb repeatedly uncovered details that hinted the universe might be more complicated than previously believed. Some of its most beautiful images came from places much closer to home. When Webb observed Neptune using infrared instruments, the familiar blue planet appeared completely transformed. Methane in the atmosphere absorbs infrared light, causing the planet itself to look unexpectedly dark while revealing delicate rings, faint atmospheric features, and wispy clouds with stunning clarity. A world humanity thought it already understood suddenly looked almost unfamiliar. The same pattern appeared again and again. Every time Webb pointed toward another target, hidden structures emerged from the darkness. Astronomers soon realized they were entering a completely new era of observation, one where the invisible universe was becoming visible for the very first time. But the greatest surprises weren't waiting inside our solar system. They were waiting billions of light years away, in a time when the universe itself was still in its infancy. And those discoveries would begin challenging some of the most fundamental ideas about how everything we see today first came into existence.